Hi, Paul here from Easy Composites. In this video guide, I'm going to demonstrate how to use the Uni-Mould tooling system. I'll cover everything that you're going to need to know to successfully produce molds with it, using this side blade mold as an example. We do have quite a lot to cover in this video, so I'll break it down into the following sections. We'll be taking a materials overview, we'll look at suitable pattern surfaces and materials, release agents, the working environment, then we'll go on to consider the mixing and application of the gel coat, the coupling coat, and then the tooling resin, before considering curing times, and then finally we'll be looking at mold finishing and repair methods. Uni-Mould is a highly versatile mold making solution that produces accurate, durable and cost-effective molds that can be used for most composite processes, including resin infusion, RTM, wet layup and vacuum bag processing of epoxy, polyester and vinylester resin systems. This makes it ideal for ambient and medium temperature cures up to 90 degrees C, so it is suitable for nearly all applications, with the one exception of pre-preg moulding, where a high temperature epoxy system is going to be more suitable. Working with Uni-Mould is very much like working with traditional fiberglass mold materials, but it does differ in a few key ways. Firstly, it has a highly durable and polishable vinylester gel coat, which, unlike traditional polyester gel, offers excellent release performance with epoxy resins, and it's also less prone to scratching and cracking. This gel coat is then backed up by a high-performance vinylester coupling coat, and this creates a seamless bond with the gel and also minimises the risk of getting air entrapment between the plies. Following this, 4 plies of chop strand mat are applied in one go using a special filled resin that cures with minimal shrinkage and distortion, which, as you may know, can often be problematic with traditional fiberglass resins. In summary then, Uni-Mould is a cost-effective and time-efficient mold making system that's often going to be the best choice for low and medium temperature processes. The system comprises of 3 different types of resin. We have the UG1 Gelcoat, the UC1 Coupling Coat and the UT1 Tooling Resin. Then we have 2 different types of reinforcement. We use 2 plies of the lighter 100 gram chop strand mat with the coupling coat, and 4 plies of the heavier 450 gram chop strand mat is used with the tooling resin. Probably the most convenient way to purchase these materials is in kit form. These kits include all of the materials and tools that you'll need in the right ratios. We have 2 options here. We have the smaller kit, which is the one on the bench, which is based on 5 kilograms of resin, can produce 0.7 square meters of mold. So that's about the same size of this part, including its flanges. Then there's the larger kit, which is based on 25 kilos of the tooling resin, and that's going to cover 3.3 square meters. Of course, we do supply all of these materials separately. If you are ordering in this way, then these are the approximate quantities that you're going to need per square meter. So per square meter, we need 1.4 kilos of the UG1 Tooling Gelcoat and the UC1 Coupling Coat, and 7 kilograms of the UT1 Tooling Resin. All of these resin systems are catalyzed with standard reactivity MEKP catalyst. Note that if you are outside of the UK or mainland Europe, such as in the United States or Canada, then we may not be able to ship this to you due to very strict shipping regulations that apply to it. Fortunately though, this type of catalyst is used for conventional fiberglass resins, and so you should be able to source it quite easily locally. I would suggest looking for flat roofing materials suppliers or boat chandlers or maybe automotive paint supply shops. Wherever you do source it from, do ensure that it's within its shelf life, as out-of-date catalyst is hard to identify and can cause some serious problems with the cure. The starting point for any mold is the pattern or original part that you're going to be pulling the mold from. As Uni-Mould cures at room temperature without vacuum, most materials and finishes will be compatible with the system, but this does not mean that you can pull a mold from absolutely anything. So let's cover the most common finishes that you're likely to be using. Firstly, paint. Nearly all OEM painted panels like this side blade will be fine. Oven cured 2K paints do not generally react with the system. However, and probably the most common mistake that we find people will make is to paint a pattern with a 1-part gloss or clear coat. Now these will nearly always get attacked by the solvents found in vinylester and polyester gel coats, and so I would strongly advise never attempting this. Even when you're using good quality 2K paints, you can still have problems if it's not been fully cured. So generally you're going to need to oven cure the part before pulling your mould. If we now consider dedicated pattern coats like pattern coat primer and pattern coat gloss, as you would imagine, they provide a very stable and reliable pattern surface to any underlying material, be that model board, MDF, wood, metal, compatible foams, and so these are normally going to be the best choice for finishing new patterns or refinishing modified panels or parts. They also don't need an oven cure and can be easily applied by spray or brush. Then we have plastics. Most plastics offer natural release properties and will be compatible. These compatible plastics include polypropylene, polyethylene, nylon, polyester, acetyl, PVC and PTFE. Now there are some plastics that do not provide a good release. The most common problem plastic that you're going to encounter is ABS. And ABS is used quite extensively in automotive applications, particularly on interior trim. If you take a look at the back of the part in the code, it will normally tell you what it's made from. If it says it's ABS, then unfortunately the styrene in the resin is going to partially attack and dissolve the surface, which is going to cause them to fuse together. If you did need to pull a mould from an ABS part, you can do this, but you will first need to coat it with a pattern coat or an epoxy. There are also some other plastics that don't release well. The plastics that I would avoid are ABS, as we've just discussed, polystyrene, as that dissolves with the styrene in the resin in just the same way, and then we have polycarbonate and acrylic. These, although less affected, can experience some level of etch when exposed to solvents, and so I would avoid those too. Then we've got metals. Any bare metal surfaces can be used as a pattern, so pulling moulds directly from things like engine covers or folded metal profiles is going to be fine. Then there's epoxy coatings. Sealed epoxy coatings like the XCR coating resin make for a fully compatible pattern surface, and their excellent leveling and bonding characteristics make them probably the best choice if you're using a 3D printed pattern and want to smooth out those layer lines. Body filler or Bondo. Really deserving of a special mention, polyester body fillers will nearly always cause a mould to stick unless it's been completely sealed with a pattern coat or an epoxy coating. I've done this myself and we've seen this problem a lot. It's understandable, as so often these fillers are the perfect material for finishing a pattern or making a modification to a part prior to pulling a mould. If you do use them then, I will reiterate they need to be completely coated, as relying on release agent alone will almost definitely result in your pattern and mould bonding together any areas where you've used it. On a final and important note on pattern materials, if you are in any doubt whatsoever as to the compatibility of the surface, maybe it's an unknown paint system or plastic or just a brand of 2K paint that you've not used before, do a test. Simply prepping and applying a small patch of gel and checking that it easily releases 6 hours later is going to tell you whether you're going to have any issues. And a small amount of patience at this point could save you the hours of time that have no doubt already been put into your pattern. When it comes to release agents, the Uni-Mould system can use all conventional release agents that you would use for normal fiberglass moulding. So that's liquid wax, paste wax, PVA or chemical release agent. And so if you have a preferred method that works well for you, feel free to stick with it when you're working with the Uni-Mould. Wax does produce excellent surfaces and reliable releases, but it does take time to apply and relies on good application technique. PVA is really useful for quick, reliable releases on lower quality patterns, but it's not going to leave an A-class finish, and so you might need to sand and polish your mould if you do need that quality finish. Chemical release agents like CR1 are typically the most reliable, and they do offer excellent surface finishes. I use this almost exclusively for all of my processes, and so if you're unsure of which to use, this would definitely be a solid choice. Whichever release agent you do decide to use though, ensure that you fully familiarise yourself with its proper application procedure. The working environment can have a large impact on how the resins cure. The main factor here is temperature. The Uni-Mould system is designed to be used at between 18 and 25 degrees. In this temperature range, the resins will have good pot life and will cure properly without excessive shrinkage. Below 18 degrees and the curing times will be significantly extended, which could cause problems with chemical attack on your patterns and cause an incomplete cure. Above 25 and your working times will become greatly reduced, and you could face problems with exothermic thermal runaway and excessive shrinkage. Even when you're working within this temperature range, you will often choose to adjust the catalyst ratios to adjust the cure speeds, and more on that later. Another important factor on your working environment is ventilation. In common with all polyester and vinylester resin systems, Uni-Mould releases styrene during cure and should only be used in a well-ventilated area or even outside. Generally, for smaller moulds, the passive ventilation that you're going to get by opening a window and a door will be sufficient to stay within safe limits. But for large moulds or in confined spaces, mechanical ventilation would often be needed. Note that styrene does have a very strong smell, even in concentrations well within safe limits, and so you might need to consider co-workers or even neighbouring buildings when you're producing moulds. Before we get into it, we've got one last area to cover, and that's PPE. Whenever you're working with resins, you should wear splash-resistant goggles and nitrile gloves. And when you're working with a laminating roller, you should also wear long sleeves, as this is going to protect you from the spray that's caused. Finally, a mask with a vapor or a VOC filter should be worn if you're not completely sure whether your ventilation is sufficient. This is the example that I'll be demonstrating with. It's an OEM panel with its original 2K paint. I prepared this with 6 applications of CR1 chemical release agent, and now I'm ready to attach my barriers. Using polypropylene sheet, the barriers are attached to the part using hot melt adhesive. In this case, you will see that the barriers are being attached to shims to space them from the edge of the part. I've chosen to do this to create a small extension to provide some trim allowance on the final moulding. The gap between the barrier and the part is then closed and sealed using filleting wax. This wax is really easy to apply, but modelling clay like plasticine will also work for this. The assembly is then put onto a stable support and it's ready to have the mould made. This part's now all prepped up ready, so we can get on now with the first gel coat application. The gel coat forms a hard-wearing, polishable and airtight surface to the mould. In most cases, this gel should be applied in 2 even coats to ensure a complete thick coverage. You will need around 500 to 700 grams of gel per square metre per coat. This is weighed out and the MEKP catalyst is added. Under-catalysing here is more of a risk than over-catalysing with this gel. Generally, I use 3% when working at 18 to 20 degrees C and reduce this to no less than 2% when working closer to the maximum 25 degrees C. Once thoroughly mixed, the gel should then be brushed evenly over the entire surface. To ensure an even coverage, I like to dot the entire mix at regular intervals over the pattern and then brush it out from here. When doing this, pay particular attention around the bottom of vertical surfaces, as this is where the gel can pool. If you were to leave areas pooled up like this, then there is a strong risk of the gel coat excessively shrinking while it cures, which can lead to pre-release and areas of distortion. Once you're happy that the coat is even, it can be left to cure for 4 to 8 hours. Okay, so while that's curing, let's talk about 2 important factors for achieving a good cure. Firstly, cure time. While 4 to 8 hours plus is the minimum amount of time you'll need, this is going to vary depending on the catalyst ratio used and the working temperature. You can tell when a gel is sufficiently cured because it might still feel very slightly tacky, but it shouldn't indent or move when it's firmly pressed on. Unlike with epoxy gel coats, vinyl esters really can't be left too long, so if you're at all unsure, then simply wait a few more hours. In fact, even days later, you're still going to get excellent adhesion between coats. If you don't leave enough time for it to cure, then there is the very real risk that the next application is going to soften and attack the first, leading to a wrinkling effect, often referred to as alligator skin. If this does happen to you, you'll just need to leave these to cure, then remove them and start all over again. Applying backing coats too soon is one of the most common mistakes people will make when new to this, so please do exercise some patience here. Secondly, during cure, styrene gas is released from the gel, and this is a heavy gas that will pool in the bottom of deep moulds and features. And this pooled gas then inhibits and slows the cure of the gel, meaning you might not get a full cure when you would otherwise expect to. So if you do have a mould with deep features like this, you need to set up a fan at the side of it to blow air over the top and remove that styrene. With the first gel cured, I'm now applying a second application in exactly the same way as the first. On simple flat moulds, a second gel is not necessarily required, but in most cases it is a good idea as it will ensure that you have a good thickness of gel everywhere, which is going to reduce the print through and allow for more flatting and finishing on the mould. Again, this second coat is allowed at least 4 to 8 hours to cure solid. Now we're on to the reinforcement. The first plies of reinforcement are 2 layers of a lightweight 100 GSM chop strand mat. This should be cut to size prior to mixing the resin. If you have detailed features, you should be tailoring multiple pieces to conform to the shapes. When doing multiple pieces, you should allow a small overlap to ensure that you get a full coverage of reinforcement on your mould. When doing this, it's often best to tear the edge of the matting, as this is going to give you a feathered edge that's going to blend nicely with the adjoining pieces. The coupling coat resin can now be mixed with 1.5 to 2% MEKP catalyst. This resin is quite quick to cure, so I would typically use 1.5% unless it was a particularly small mould. You will need approximately 1 to 1.4 kilos of resin per square metre of mould surface. If your mould is larger than 1 square metre, then I would suggest mixing in batches of no more than 1.5 kilos at a time to ensure that you have sufficient working time within the pot life of the resin. Once mixed, a coat of resin should be applied onto the gel coat, and then a layer of the 100 GSM chop strand can be laid down and then further wetted out with resin. This matting has a binder that holds the fibres together, and this binder then dissolves with the resin, meaning that you can first apply the resin with brush strokes, but once it's wetted out and saturated, you should use a stippling action to avoid moving the fibres around too much. When properly saturated with resin, the matting will be almost completely transparent. For these first 100 gram plies, generally only a brush is needed as they are a bit too thin for a roller to work effectively. More resin is then applied and the second ply is wetted out and laminated in just the same way. This lightweight 100 GSM matting is used for these first layers as it does conform really well to intricate details and it creates minimal print through onto the surface of the mould. Unlike the tooling resin, which we'll be using later, the coupling coat has very good transparency, meaning that any dry areas or bubbles can easily be identified and worked out. Do pay particular attention in the corners where air will often become trapped. If you find there are any air pockets, they should be stippled out with a well-saturated brush. Once you're completely happy that the matting is fully wetted out with no air pockets or voids, then it should be left for 4 to 8 hours to cure. After curing, inspect your mould for any coarse nibs or splinters, which should be knocked down with a coarse sandpaper so that they won't interfere with the next layers. The main reinforcement can now be prepared. This comprises of 4 plies of a heavier 450 GSM chop strand matting. Tailor this to size in just the same way as you did for the first plies. Again, tearing the edges of your reinforcement will allow for a better join. The UT1 tooling resin should then be thoroughly shaken up or mixed to disperse the fillers which settle to the bottom when stored. You will need approximately 7 kilograms of the UT1 per square metre of mould, which is then mixed with 0.75 to 1.25% of MEKP catalyst. I typically use 1% unless working at the far ends of the working temperature range. Laminating with the tooling resin is much the same as doing traditional fiberglassing. So we apply a thick coat of resin over the entire surface and then drop down a layer of matting and wet it out using a brush and then consolidate with a brush stippling action and a roller until the layer is completely and evenly wetted out and saturated with resin. Then we repeat this for the remaining 3 layers. Unlike normal fiberglass resins, this system does need all 4 layers to be applied in one go to work properly, as it relies on its exotherm to reach a full cure. But because of its special fillers, it's not going to excessively shrink or distort like a normal polyester resin would do. If your mould is larger than 1 square metre, then it's unlikely that you'll have enough time to properly wet out and consolidate all 4 layers with one batch of resin. So what you should do in this case is laminate the mould in strips of approximately half a square metre at a time with all 4 plies, then mix a new batch of resin and continue to work your way down so that the cure will follow you as you work your way along. Have a look at the video where we make a mould for an expedition sledge to see this technique in action. Once you're happy that all 4 plies are properly wetted out and consolidated, the mould should be left for 24 hours to cure. Do make sure that during this time you maintain a stable temperature of between 18 and 25 degrees C. As the resin cures, you will notice that the resin will change to a much lighter shade of colour as it peaks on its exotherm and reaches that full cure. We're now 24 hours later and we have a cured mould. The temporary barriers can now be peeled away and the pattern part removed. If the pattern surface was properly prepared and compatible, it should pop out with very little effort. The mould can now be trimmed. Most conventional tools will work for this. Here I'm just using a permagrit blade in a jigsaw, but also a cut-off wheel in a grinder is another fast trimming tool, but it does kick up a little bit more dust than this. The edges are then flatted with a permagrit block. Okay, so now that this is all trimmed up, we have what is effectively a finished mould. And while in certain situations you could simply apply a release agent to this and put it straight into service, there are a few final steps that might be needed. Firstly, if you plan to use this mould at temperatures above 40 degrees C, then you will need to conduct a post-cure to get that maximum service temperature from the system. The standard post-cure for Uni-Mould is 10 hours at 60 degrees C, followed by 2 hours at 70, 80, and then finally 90 degrees. But don't worry if you don't have an oven, you don't need to do a post-cure if you're only going to be using these moulds at ambient temperature for something like a standard resin infusion. The next thing to check on your mould is if there is any repair or refinishing work needed. It's not uncommon to get small raised nibs like this, particularly where the filleting wax has been used. If you do find any blemishes like this, they should be sanded smooth with 800 followed by 1200 grit abrasive and then polished in with some NW1 polishing compound. If you were to just leave these, there is a risk that when you come to mould the part, it's going to mechanically lock against them and could chip or damage your mould. So what about damage repair then? If you do find that the gel coat is chipped or cracked either during mould production or later when the moulds are in service, then that damage should always be repaired before use. Fortunately, this is generally a very straightforward thing to do. The damaged area should be worked down first to a good solid base or substrate material. It should then be scratched up and sanded to provide a mechanical key, and then some catalyzed gel coat is mixed up along with 2% of MW wax additive solution. The reason for this is, like most polyester and vinylester gel coats, the surface where it's exposed to air won't cure fully, and that can leave a thin, tacky film, which makes sanding and polishing them challenging. But by adding in that wax into the solution, it will create a seal over the surface, meaning that it can cure fully, allowing for easy finishing in the end. This gel coat is applied so that it sits just proud of the surface of the surrounding material. Once the gel coat repair has fully cured, it should be sanded in flush, working through the grades to 1200 grit or maybe higher, before polishing again with NW1 compound to leave a seamless repair. Finally, surface refinishing. This really comes down to the quality of your original pattern and then the importance that you have on the cosmetic finish of the final part that you're making. If you look closely at the surface of this mould, you will see that we do have a slight ripple. A small amount of this may be coming through from print through from the chop strand matting, but the vast majority of what you see here is an orange peel effect that's transferred from the OEM paint finish on that original component. Now, this mould could definitely be left like this and it's still going to go and produce excellent parts. But if you did want to take the finish one step further, then the mould surface can be flatted down using 1200, followed by 15 or even 2000 grit, and then polished up with compound to provide a perfectly flat mirror-like surface. If you are planning to do this, it should be done after you've completed the post-cure. That's if you're doing a post-cure at all, as this will ensure that the mould surface is already fully stabilised before doing the flatting. The very last step is going to be to apply 6 applications of CR1 chemical release agent, and then the mould is ready to start producing its first parts. That really covers everything that you should need to know about using the incredibly versatile Uni-Mould system. But of course, if you are left with any questions at all, please don't hesitate to get in touch with our technical team, who will be more than happy to help.